Welcome back to the garage. Today, this video is going to go along with task sheet 711. This is diagnosing drivability concerns without any check engine lights. So we're going to walk through this a little bit. This is kind of a hard problem to duplicate in this setting, but we're going to do the best that we can. This is based off of something I actually encountered out in the field. So our customer complaint today is that we're getting this intermittent kind of surge or a rough idle, a stumble. So we're going to take a look and see what we can't find. Again, no check engine lights to go along with this thing, so we're going to take a look and see what we can find. We got the truck running. I'm going to kind of show you guys what we got going on. This thing will idle pretty normal, and then it just wants to fall on its face. Sometimes it'll actually die. Oh, there it goes right there. So this thing is actually dying. Sometimes it doesn't, sometimes it will, but it kind of comes and goes. So we got to try and see if we can't figure out what's going on with this thing. Again, no codes. I didn't see any bulletins. So we're going to take a look at our data display and see if we can't see anything pop up. So here we got our data display up, looking at a couple parameters here. Everything's looking good at the moment. Unfortunately, I only got one hand. I can't really scroll through this at the moment, but as we're looking, we want to make sure everything, is kind of looking normal, is reading okay. I don't know if you guys caught it. You may want to rewind and take a look at that again, but we saw something dip real quick on our data display right as our engine died. Keep a close eye, maybe you'll catch it, see if you can't see what it was. So what we actually have going on here, you can see it every once in a while, our coolant temperature sensor is dropping out. I had one of these do this out in the field. You sit there and watch the data display and it do just that. All of a sudden it dropped down to minus 34 degrees. So typically in a temperature sensor circuit, if you're going full negative, that's kind of meaning an open circuit. If it goes all the way up the other way, that is going to be a short. And that is a way that we can kind of test some of these circuits. So we'll go ahead and do that here real quick so I can show you guys that. All right, so we got our sensor unplugged and we're going to short this thing together. I've got a little switch that I'm using to make it a little bit easier on myself, but open circuit is typically going to go maximum negative, which is usually minus 30 to minus 40. And when we short this thing together, you see we pop up to 284 degrees. That's going to be the maximum range of this sensor. So that's a quick and easy way to see if the PCM is responding to input from the sensor. Now, it doesn't mean you don't necessarily have a wiring or PCM problem. It could be a terminal issue. One thing to keep in mind with kind of intermittent stuff like this is that sitting still, it may never do anything out of the ordinary. But once you start the engine and get some vibrations and stuff going, that can actually trigger these problems, especially if it's something like a terminal or a wire. It doesn't take much of this thing running, just a little bit of vibration to get some of these problems to show their face. So we're going to continue testing a little bit and see if we can't track down this problem. Another note, you can do this with a lot of temperature sensors, either coolant temp or intake air or ambient temp. You can also do this with things like oil pressure sensors. So it's just a quick little test. And sometimes I looked on this truck and I figured it would, but for some reason it's not. A lot of times when you make the switch like this, the gauge on the dash will also move. So sometimes if you have gauge issues, if you want to see if it's maybe the cluster, like the needle's not moving, or if you think you have an input problem, that's one way you can isolate it. So if you change back and forth and your needle follows from full cold to full hot, then it's probably not going to be in the cluster. So just another little test that you can run sometimes. Like I said, again, I'm not really sure why it's not doing it on this truck. I'd have to look into it a little bit more, but that's just a quick little functional test, and we'll keep going, see what we can't find. So one thing we can do if we think we have a temp sensor problem is catch this thing when it's cold, as it's sat overnight. And what we want to do is compare a couple of sensors together. So we've got our coolant temp sensor reading at 60 degrees, and what we want to do is compare that to our intake air temp sensor. More modern vehicles is going to have a third one. There's probably going to be an ambient air temp sensor that we can look at also, and they all need to be fairly close. You see we got 60 on our coolant and 68 on our intake. It's a little chilly overnight, so it's not that unusual for the coolant to be a little bit colder than what's in the intake. So I would say that that's probably going to be close enough to calling it okay. Now, if our intake air if we were off a bit more, I would probably take a look at it, but just kind of knowing the weather conditions right now, we're going to call that acceptable. But that's one thing you can do if you ever have an issue like that. Try and catch it cold and compare those sensors together. It can kind of help you see if you got anything weird going on. So one of the tests we can do is a simple resistance check. I'm just hooked up down here to my temp sensor using my little terminal probes there. So we're reading 833, 834 ohms. Don't forget to make note of your scale. We're on the thousandth scale, but we're below the decimal point. So we're reading 836. So now there's two things that we can do is take this resistance measurement and compare it to service information. There's going to be a resistance versus temperature chart that we can compare this to. And we can also take a heat gun and measure right at our sensor to make sure that we're kind of close. So we take all three of those things, our actual sensor reading out of the data, our resistance, and a temperature check with a heat gun, and kind of compare all three of them to make sure that this thing's kind of reading right. So we'll hit this with the heat gun here real quick and see what it looks like. It's kind of hard to show. I got my little heat gun here. The ones with the lasers are going to work a little bit better. Let's see if we can do this. This is kind of difficult to do with one hand. What was that, 118? 116. We'll go with that. That sounds pretty close. So what our sensor was reading in the scan tool. So we'll check against the chart here real quick and see what our resistance looks like. So here's a look at our chart here. So we had high 800s as far as ohms go. So that's going to put us somewhere in between 50 and 60 degrees Celsius, which is 120 to 140 degrees. So we're going to be pretty close on our resistance measurement versus our data display versus our heat gun. So it's not exact, but we want to be kind of in the ballpark to make sure this thing is working okay. But we're gonna check some wires out here real quick, and we'll go from there. So I've got our diagram pulled up here just to take a look and see what we have in the circuit. What I want to do is ohm out the wires from end to end. And one thing that we need to know is what all's in this circuit. So this is pretty simple. There's no extra connectors or anything. It goes straight from the PCM to the coolant temp sensor. So we want to go from connector 1, pin 74, to pin B, which is the yellow wire, end to end, and then pin 63 to pin A, the gray wire, end to end. If this thing was just flat dead, this coolant temp sensor, I'd take a look and see if this 5 volts up here is actually getting out to the sensor. Some of these vehicles will have a common 5 volt signal that will hit maybe 4 or 5 different sensors, and I've seen this happen before. You'll get one shorted sensor and it will pull down the whole 5 volt circuit and it will kill all the sensors. So that's one thing to keep in mind. Sometimes these sensors can share, and one bad sensor can wipe out some of the other ones. So just one more thing to keep in mind. But we're going to ohm these out end to end and see what it looks like. So we're hooked up on our wires from PCM to our sensor using the correct terminal probe. If you don't have the right terminal probe, that's okay. You can use something small to touch off to that terminal in there, but don't just like jam a paper clip or something in there. It's going to damage the terminal. I really can't preach enough about these terminal tools, especially nowadays. There's ways around having them, but I mean, if you're doing electrical work, they're definitely worth it. So you can see we're kind of down here in our connector. So what we want to do when we're doing resistance checks like this, running wires end to end, is kind of look at your harness and see how it flows from your PCM over to your sensor. And you just want to grab a hold of these harnesses and start moving stuff around. See if any of this stuff changes when you're moving it. I mean, they call that doing a wiggle test. I don't know if you guys have heard of that before in any of your other classes, but just move this stuff around, and sometimes you'll catch this resistance jumping around as you move stuff. That's one way you can help kind of find some intermittent conditions. So I'm gonna switch this over real quick and run the other wire and see how it looks. So we're switched over here to pin 63, and then our other wire on our sensor. We're running under an ohm. And one more thing to note on a circuit like this is that this sensor is based off resistance. So if we have any additional resistance in our wires, that can skew our reading on our sensor. So it's something else that we need to look for. But all our wiring checks okay, everything looks good. So we're gonna call this a bad sensor. Sometimes you can get these to act up if you tap on them a little bit, but the one that I had encountered in the field, we could catch it switching resistance kind of on its own, so I threw a sensor in it. But that's it for this one. Fill this out the best you can, and we'll move on to the next one.